Hi everyone, I'm Kaushik from Mechanical Second year. I'm going to tell you about sinusoidal waveform. So in this PPT, we are going to see what is a sinusoidal waveform, generation of sinusoidal waveform, and sinusoidal waveform. First, let us know what is a sinusoidal waveform. So sinusoidal alternating waveforms are time-varying periodic waveforms with parameters including voltage and frequency. A sinusoidal waveforms are used to represent the AC quantities. There are many ways to represent the AC current, like square, rectangular, sawtooth, etc. But we choose the sine function because the sine wave changes its value at every instant of time and for easy calculations. So a sinusoidal waveform is used to represent the AC quantities. So a sinusoidal waveform is used to represent the AC quantities. So there are many ways to represent the AC quantities, but we choose only sine wave because the sine function changes its value at every instant of time. It changes its value at every instant of time. So let us consider a sine wave. So if we want the value at pi by 6, it at this instant we get the value at pi by 6. If we want the value at pi by 3, we get the value at this instant. So in a sine wave from 0 to pi, at every instant of time, it changes its value. At every instant of time, it changes its value. But in square waveform, in a rectangular waveform, sawtooth waveform, triangular waveform, the value remains constant. The value remains constant in horizontal or in vertical. So to represent the change in values at every instant of time, we choose the sine function. So a sinusoidal waveform represents the AC quantity. So let us know how this sinusoidal waveforms are generated. When electric current flows through a wire or conductor, a circular magnetic field is created around the wire and whose strength is related to the current value. If this single wire conductor is moved or rotated within a stationary magnetic field, an EMF, electromotive forces, is induced within the conductor due to the movement of the conductor through the magnetic flux. From this, we can see that there is a relation between the electricity and magnetism. So the electromagnet is induction, and it is the basic principle of electric machines and generators used to generate sinusoidal waveforms for our main supplies. So uh, a wire loop, a conductor or a wire loop is placed between two permanent magnets, North Pole and South Pole. So there is a continuous generation of magnetic flux from North to South Pole. So when the wire loop is placed in between the North and South poles, so when this wire loop cuts the magnetic fields, it induces some electromotive forces. So the electromotive forces are induced within the conductor, within the loop, and there it leads to the generation of the AC current. So here you can see. So whenever the conductor cuts the magnetic flux, so the electromotive forces are induced within the conductor and it leads to generation of the current. So here you can see from whenever the wire loop or the conductor moves from point A to C. Point A to C, it cuts the magnetic field. It cuts the magnetic field and it leads to the generation of the electric current, which is AC current. So also, the conductor cuts the magnetic field at different angles between point A and B, 0 and 90. The amount of induced in EMF will lie somewhere between 0 and the maximum value. Then the amount of EMF induced within a conductor depends on the angle between the conductor and the magnetic flux, as well as the strength of the magnetic field. So the induced EMF, the amount of induced current depends on the angle between the conductor, the magnetic flux, as well as the strength of the magnetic field. So an AC generator uses the principle of Faraday's electromagnetic induction to convert a mechanical energy such as rotation into electrical, a sinusoidal waveform. So here we can see at A, the wire loop is in vertical position. So at B it is in horizontal position. So from A to B it cuts some 90 degrees. So here you can see from position A to B it cuts the wire loop cuts the magnetic field lines, magnetic flux at 90 degrees. So there is some generation of electric current. So some electromotive forces are induced within the conductor and it leads to the generation of the electric current. So here you can observe a half curve. So from B to C again it rotates some 90 degrees. So here it from A to C it is positive, from C to D it is negative. So this is an AC power generator. So this is the wire loop, wire conductor which rotates, and these are the magnetic field lines from north to south pole. So when I so now the wind strength is 2 minus 2, so means minus represents it is rotating in an anti-clockwise direction. So you can observe there is a generation of the sine wave. Whenever the conductor cuts the magnetic field lines, it leads to generation of the AC current, and which is represented in the form of sinusoidal waveform. So now you can see it is cutting the magnetic field lines. So here you can observe for every 180 degrees it changes the direction. The current changes the direction. So here you can observe the change in direction of the current. So now let us see sinusoidal waveform construction. The point on the sinusoidal waveform are obtained by projecting across from the various positions of rotation between 0 to 360 degrees to the ordinate of the waveform that corresponds to the angle theta, and when the while loop or coil rotates one complete revolution 360 degrees, or one full waveform is produced. From the plot or the sinusoidal waveform, we can see that when theta is equal to 0 degrees, 180 degrees, or 360 degrees, the generated EMF value is 0. So here you can observe whenever the angle between the while loop and the magnetic field lines is 0, the EMF induced or current produced is 0. Whenever it is 180 degrees, again it is 0, and at 360 degrees it is 0. But when theta is equal to 90 and 270, the generated EMF is maximum value. So whenever it has a angle of 90 degrees and 270 degrees, the generated EMF value is maximum 100 minus 100. So here you can see at the position A it is 0 and 360 degrees, so the produced EMF value is 0. Again, after rotating 90 degrees, it produces a peak peak voltage, peak EMF is generated at 90 degrees. Again, after rotation of another 90 degrees, it goes to 180 degrees. Again, at 180 degrees, it produces zero current. Again, from 180 to 270, it rotates 90 degrees. Again, at 270 degrees, it produces a peak EMF of minus 100. Again from 270, again half rotation, it goes to 360 degrees. So it completes one complete revolution. Again it produces 0. So one complete revolution produces one full waveform. So one 360 degrees rotation of the copper coil or wire loop or coil rotates, it generates a complete sine wave. So at 90 degrees and 270 degrees, it produces a peak EMF, and at 0 degrees, 180 degrees, and 360 degrees, it produces zero EMF.